our first presenter is virtual. So this is Julie Bolduc-Duval from Canada. And Julie, I believe you're here. You're being pinned. Fantastic.
Yes, thank you very much. Can all hear me?
Yes.
Yes.
Perfect. Well, hello, everyone. So yes, I'm joining you from Canada. I actually live in the path of totality in southern Quebec, so very happy about that. But I run a program, a Canadian astronomy education program called Discover the Universe. We actually do everything in both English and French, so you can see the bilingual logo at the bottom as well. It's a program that's existed for about 10 years. It's now supported by the Dunlap Institute at the University of Toronto, but it's also supported by astrophysicists across Canada, so CASCA, the Canadian equivalent of AAS, and CRAC, the equivalent here in Quebec. Next. I could share my, okay, no, thank you. I could share my slides. That's easier as well. No, sorry, come back. So what do we do? Discover the Universe in general. We're really there to support astronomy education by empowering educators. So we usually don't talk to the students directly, like K-12 students. We train their teachers or any school professionals, really. So we provide training and resource development. And this is a bit sort of the take we took for the Eclipse planning as well. So you can go to the next slide. Yeah, just a quick overview of the totality in Canada. Like I see sometimes the maps, they don't quite go all the way to Eastern Canada. But there are 6 provinces that are touched by totality. So Southern Ontario, it's heartbreaking for Toronto, which is just 99.8% or something. Half of Montreal gets it, Sherbrooke, then we go into Quebec. So Montreal, Sherbrooke, Quebec City doesn't have it. Then we through Maine, and then New Brunswick. Oh, I guess because I'm not sharing, I guess can I take this? So anyway, this is New Brunswick here. Thank you. And then Prince Edward Island and yeah, Newfoundland. So sorry, it's a bit hard. And I realize if I do that, I think it's going to stay for the next slide as well. My little, can I do that? There we go. I think I'll do that. That's better. Okay, so next slide. Anyway, I just wanted to show a bit that it's touching 6 provinces. Nova Scotia is just a tiny, tiny bit, but still there. So next. Can you click next? Thank you. Feel free to click all of them. I just realized that I thought I would be handling my slides, so it might be easier just to have everything all at once after all. So we decided to work. I mean, we're a small team. I'm the only full-time, but now have 4 part-time employees. Many of them are here. Actually, I'll mention them at the end. But we're still a very small team. So the best idea actually to reach as many teachers as possible was to work with many, many partners. And we work with education partners, outreach organizations, some astronomy in the astronomy community as well. So we're really trying to have as big an impact as we can, even though we're a small team. So we started, and one of the initiatives is to start a National Education Eclipse Committee. And I'm co-chairing it with Laurie Roche from the RASC, the Royal Astronomical Society of Canada. I don't know if Laurie's here. I know she's registered, but I don't know if she's here today. So we have representatives from all 6 provinces touched by totality and national partners. And I think that has helped get the ball rolling in some provinces where there were less of an astronomy community, especially for education. So that actually has been working well. With Discover the Universe, we started a community of practice, actually 2 of them, one in English, one in French. Everything is virtual. And the goal is really to empower teachers and, again, any education professionals to be leaders in their communities. And that has been working quite well. Actually, we know some teachers have been, going to their principal and saying, we need to buy Eclipse glasses, or some school boards that have bought Eclipse glasses for everyone in the school board. So that has kind of get the ball rolling in some communities. It's hard to know exactly like how many of them are, because they don't always tell us when they manage to do something, but we know it's been working well for quite a few of them. So that's I think a format that worked well for us. We also have an Eclipse newsletter that hasn't been super active, but we'll definitely get it going more in the fall, and as the excitement builds up for the Eclipse. But we were really trying to get people ready early, as many of you are as well. So next slide. But of course, there are many challenges. I couldn't be there this morning for the other sessions, so I'll watch the recording, but maybe some of this has been discussed. It's really hard for us to get teachers and school administrators to care, especially with this sort of post-pandemic burnout. Teachers have always been super busy, but now they seem like burnt out, like exhausted. They have so much to take care of. They're busy figuring out how they're going to go through the day, or what they need to do tomorrow. it's pretty hard to get them to care about something that's coming in a year or now 10 months. So that has been tricky this year. So you just need, what we've realized is that you just need one champion, like one really keen person per school or per school board to really get the ball going in that organization. But sometimes it's hard to get that person. And even if that person, like we have some keen teachers who said they've been trying to get the school administrators to care and find funding for the glasses, and it's not happening. So it's really hard sometimes. And again, get funding for glasses, I think that's an issue for everyone. Right now, what we were trying this fall is really to get the schools and the school boards to buy their own glasses. We will have some. We also struggled to get funding for glasses. We had a funding proposal that was accepted, but we had 3 so far that were rejected. But we will have Eclipse glasses to distribute in the next school year. But for now, because there won't be enough for everyone, we've been really trying to get school boards to buy their own if they could. And of course, another challenge is the timing of totality in Canada, because in Ontario and Quebec, it's right at 3:30 when many schools end, like it's the end of the school day. So we want to make sure the kids are not in the school buses during totality. So that's another thing we want them to know about and plan for it, like hold the buses, plan an activity, or however you want to do it. And of course, it's after school in Atlantic provinces. So that's going to be a different challenge as well. Okay, last slide. I'm keeping it short. I know we're going to have time for discussion. So here's my email address. Some of you want to reach me. We do have an Eclipse page on our site. It's really sort of a temporary page right now, just to kind of get information going, like what you need to do now for teachers. In the end, it will be a very pretty page with what is an Eclipse and all sorts of information. We will develop some educational material as well, but we know many other groups are doing that. So we might just find, we'll have some and then link to what other groups are doing as well. And here's the list of my people. I know some of them are here. So Lindsay, Charles, CJ have been with me for a few years, and then 2 new students who are starting now, Alicia and Daniela. So hi, if you're here. So that's it for me. I'll be happy to say more in the discussion.
Thanks so much, Julie. Oops, what's the other? Oh, no, it's on there. And Julie, one of the things that you can think about, just because you can reach out to this group as well, think about what this particular group might be able to supply for you in terms of inspiration or connections or resources or things. So just think about that. And it's great to have Canadian partners here. Okay, next up, Derrick Pitts, I believe. Yes, from the Franklin Institute. Can't wander too far with your tether.
Oh, and let me just get the together. I think I have it. Good morning, everybody. Derrick Pitts from the Franklin Institute Science Museum. I'm the Chief Astronomer, Planetarium Programs Director there. How many of you know the Franklin Institute? Fabulous. Okay. If you don't know the Franklin Institute is a hands-on science museum, like many other hands-on science museums except it's 199 years old. Yeah, right. Next year is our 200th anniversary, and we've conveniently arranged this solar eclipse to celebrate our 200th year. Happy to do it for you. Thank you very much. Okay, so Franklin Institute has been doing astronomy viewing for the general public for a long time, like many places do. But the Franklin Institute building, where we are right now on the Parkway in Philadelphia, opened in 1934. And in 1934, when we opened, we were the second planetarium in the United States. We were also one of the few buildings in the United States or facilities that actually had a working observatory for the general public to observe. So on the 4th floor of the building, it houses a 25 centimeter Zeiss refractor that works really fabulously, and we use it primarily for solar observing. So for our visiting audiences that are there during the daytime primarily, we provide an opportunity for people to look at the sun and have been doing that since 1934. We burned a lot of eyeballs since then. No, just kidding. We use really, really good solar filters to give people an opportunity to see what our nearby star looks like up close. And so we've been doing this for a long time. The observatory is a great facility, but it's small. So when it comes to eclipses and big events like this, sometimes it can be a big challenge for us to host a lot of people. It's like this. And I really specialize in creating large events, astronomy events for people to participate in, but we can't do it inside the building. Now, if we connect that with how the Franklin Institute works with our surrounding community, it actually turns out that our community connections work out really, really well for us. So we have lots of engagement, science engagement programs spread around the city, spread around the state, spread around the region, spread around the country. Lots of national partnership programs with organizations with whom we can actually do things, because if we don't have room in the building, we can engage our audiences in that way. So while we're all thinking about, there we go. While we're all thinking about doing this kind of thing, orientation, training, and preparation for our programming in our buildings or near our buildings and things like that, which we certainly did in 2017, by the way, as I prepared my museum to engage with the 2017 total solar eclipse, they thought that perhaps the audience that day at the Franklin Institute, the most visited museum in the state of Pennsylvania, they thought that perhaps maybe 3,000 or 4,000 people might show up. 10,000 people showed up, right? So they were not prepared, even though I had warned them extensively of what to expect. They still thought it was going to turn out differently. So while we were doing all this kind of preparation these days for that kind of engagement, I have another route to suggest, something that works really well for us, particularly since we are off the path of totality for both eclipses. We still have a responsibility to our community to make sure they know what's going to happen, when it's going to happen, and how to engage with it. So while we're thinking about, whoops, let me go back. While we're thinking about, I'm still getting the wrong, how do I do that? Can you go back to the beginning for me, please? Thank you very much. It's been very nice. See, yes. Okay. Trying to figure out the right button. Here it is. I'm not going to press a thing. I'm going to wait. There we go, right there. Thank you. So while we are all thinking about doing that kind of stuff at our locations, I'm going to suggest a more distributed model. And the reason why is because there are lots of other partners, potential partners in your community that will want to do something that day because they are already in place. And their particular audience, their employees, for example, can't go somewhere else. So while you announce this eclipse to your community and your engagement partners, don't forget your corporate and business partners. And here's what I mean. You have a great opportunity to create partnerships with them around this event by offering to help them understand what's going to happen, when it's going to happen, and how it's going to affect them. And on top of that, you can also offer your partner trainings to host observing events at their locations. So if you have a situation where you have a corporate partner, like we have corporate partners for support, that are going to be in operation that day and their employees can't go anywhere, you still want to help them provide a good experience for their employees. You know how a lot of businesses have bring your child to work day? Well, here is bring an eclipse to your employees day. And in this way, you can help them provide a really good, authentic science experience for their employees right where they are. The experience is not going to take all day, and people there will want to go out. So why not help them do that? So what that can do for them, you can help them assemble the materials that are needed for audience activities. You can help them figure out how to engage with their employees around this. And you can also build up connections with them. Not to mention, there's this piece down here about media engagement. Of course, they will love to have an opportunity to let the public know through the media what they've done to support this event, to allow their employees to support this event. So you can help them with that. Okay, I'm going to try the advance button. It went backwards the way I wanted. Am I holding it upside down? The little bump. Hey, it's upside down. Okay, there we go. So this is a great way to share the experience more broadly. And one of the most important things it does that I consider when I think about what's going to happen at the Franklin Institute, which of course is the natural gathering place for people for an event like this, because they know us so well for astronomy events. Well, one thing it does is it distributes the load of viewers from our location. We only have 7 bathrooms, right? And we only have so much space in which we can bring people, and we only have so many resources to share. So this does a number of really cool things. It allows the local businesses and corporate partners to provide viewing opportunities for their employees in situations where they can't leave, including hospitals, schools, daycare centers, etc. It also allows decentralization of the science experience. Science happens everywhere. The eclipse is going to be visible from all these places where the sky is clear. So why not reinforce the idea that you don't have to go to the big building downtown? We do a lot of this kind of stuff at Franklin because we need people to understand that science happens right where they are, and they can be science investigators right where they are without special equipment. So often we get from people the sense that they don't engage in science activities because they need something special, or they need a guide, they need all these other kinds of things. Well, we can help sort of like take away those barriers by this kind of decentralization of this experience. Again, as I said, it distributes the load of viewers from your location, but it also potentially builds up partnerships for future science events. So for example, one of the things I know that's going to happen for us in Philly is that some of the corporate partners to whom I'm going to offer this opportunity to receive training for how to do this, well, somebody's going to hit them up for some bucks, right? So this is a way to build that kind of connection as well. So it's just another alternative possibility for something you can do to engage more of the community. And at the same time, if I am building partnerships between the amateur astronomers and the Girl Scouts and the Boy Scouts and other astronomy enthusiasts that are going to work with us, the Franklin Institute, to help people in the Delaware Valley engage with this experience, well, in building those partnerships, what I'm also going to do is I'm going to be linking these people together for partnership building and folding them into this big experience of feeling like we're all in it together and we're all doing things together. And in that way, there may also be ambassadors that can go from the Franklin Institute out to some of these locations to help people, not just before the event, but maybe there's a way for a connection to happen where they could be there at the event too. So all of this is about building partnership and connection through your organization as the leader of all this stuff. And in that way, you're also building bridges for future events as well. Okay, let's see if I got the button right here. Great. So this is out on the Parkway at the Franklin Institute, which is where we can see some of the 10,000 people there. This is a small portion of the space, but as you can see, there's not one bathroom in sight. So the distributed experience helps to take care of some of the load on your resources where you are. Okay, that's it for this. Thanks, folks. If you have any questions. The tents? What tents? Oh, those tents. Right. Okay. So you'll see this picture, and I'll talk about this again later. But the tent thing here, if you'll notice right in the center portion of the picture here, there's maybe a laser pointer here, but you'll see the silver tent things there. I went to observe the 2017 eclipse at St. Joseph, Missouri for the past 60 years. St. Joseph, Missouri on August 21st was cloud-free. August 21st of 2017? Yeah, you bet, right, exactly. So I was out at St. Joseph, but what I had done is I'd prepared everything to happen at the Franklin Institute. We had a very large team that could work with us. I had 35 sun spotters, a bunch of telescopes, some sun guns, all kinds of stuff available. I'd already handed out 10,000 solar eclipse viewers around the city through community centers, which I'll talk about later. And we did all this stuff to prepare everybody. But I also realized as we were getting close to the time of to the date of the eclipse, that perhaps I might need some extra solar viewing material. So just by chance, I bought some rolls of material from Thousand Oaks Optical. And the solar material I bought was the black polymer viewing material. And I thought, well, I can do something with it because the price of the rolls was cheaper than the glasses. So I thought, I'll just buy some of this and maybe I'll think of something to do with it. Lo and behold, I thought of something. I thought of, why not make a solar eclipse observing tent? The tent is actually made of the frames that come with outdoor canopies. If you have some sort of outdoor event and you have the folding canopy thing with the vinyl top and the metal framing. So I got a few of those. I took the vinyl top off and instead fit the black polymer material across the top. Now, what it did was it provided an opportunity for many people to observe at once. This was to mitigate the issue of, I don't have enough individual hand viewers to go around. So if I do it this way, I can fit maybe 20 people under a tent. Wow, that's great. 20 people can see at once. But it also did something else. It made observing a group experience. So you could turn and talk, and you could share with somebody else with you. You could point and all sorts of things like that. And the other cool thing was I found that people who were in wheelchairs could easily roll underneath and look up. Somebody could sit and look up. All kinds of really cool things happened from that. So that's how the tent came about. It's really simple. It's just the black polymer from Thousand Oaks and these frames that you can buy online at Amazon. And I just had my crew tape it to the top of the frame. This year, I'm having our carpentry department make frames for this stuff, okay? And as soon as I get the design for the frames, I'll be happy to distribute that so everybody else can use it as well. It's very simple and straightforward. So that's it. Well, if you have more questions later, I'll be happy to answer them. Thank you very much.
Thank you for indulging me in that last question because it is just the coolest thing. Okay, coming up next. Oh, we have Doug Duncan from the University of Colorado.
Thank you. And I want to start by ad-libbing because I think one thing Derrick said is one of the most important things you've heard here. The private sector is really important. A lot of us in this room come from an academic background. The private sector is much, much bigger than you. And whenever you leverage cooperation with them, you can reach a lot more people, you know, and even a minor league baseball club, you know, stadiums have bathrooms, parks have bathrooms. Logistics is what any large event is about. So reach out and get partners. NASA's a great partner. I'm going to tell you in a minute that NASA funded what we're doing. And that's my cue to Angela. I think that this is going to be the last. No, don't show it yet. Okay, but this will be the last thing. My only visual is the video. So at any rate, I just wanted to endorse what you've heard because it's
the time got suspended. It was very surreal. Everyone was crazy. It was awesome. Pretty cool.
Something dramatic happens like this. It resonates inside of us because we're part of this universe.
Oh, that was mind blowing. That was so cool. I almost first
and
I almost didn't know where to look. I was watching the mountains disappear as the shadow came. I was watching the shadow bands on the ground. I watched the corona, the prominences, the planets you could see. It was, that was the fastest 2.5 minutes of my life.
But here I'm especially representing Fisk Planetarium at CU Boulder. We have had the opportunity over the last 10 years to make Fisk the most technically advanced planetarium that's ever been built. And we know that there's 1,000 planetariums in America and about 990 of them don't have production facilities to make their own 360-degree videos. So we have built up a production team. It's modest in size, it's high in talent, it's Hollywood level talent. And thanks to NASA and other funders, what we do is we make videos originally in the full dome 360-degree format, and we distribute them all for free. We're in 600 planetariums in 60 countries, all that in the last 10 years. But for the coming eclipses, we knew that there's a much wider audience outside of planetariums. So we were funded by NASA to make flat screen videos. So you can download them, as you'll see in about 1 minute. You can use them on YouTube. You can show them in libraries. You can show them in classrooms. You can show them to your mother. You can use them at home. We're really happy that we now have the funding to produce multimedia. We also are multi-language, English and Spanish so far. Okay, so I want to show you just one example. We have 2 videos released, or if you can, which are completely independently produced. And both of the versions have subscripts, by the way. You can have English subscript, the Spanish, Spanish subscript, the English so far. Yeah, so let's go ahead and show the total. Okay, I'm not going to say anything. The video says it all.
The time got suspended. It was very surreal.
Everyone was going crazy.
It was awesome.
Pretty cool.
Something dramatic happens like this, it resonates inside of us because we're part of this universe.
Oh, that was mind-blowing. That was so cool. First eclipse, I almost didn't know where to look. I was watching the mountains disappear as the shadow came. I was watching the shadow bands on the ground. I watched the corona, the prominences, the planets you could see. It was, that was the fastest 2.5 minutes of my life.
Something awesome is coming. 2 eclipses of the sun are crossing the US in October of 2023 and April of 2024. Everyone in North America will see at least part of the sun covered by the moon. The first eclipse is an annular or ring of fire eclipse, and the second one is an awesome total eclipse of the sun. Let's talk about the total eclipse. I'm astronomer Duncan, and I have been chasing eclipses my whole career.
And I'm astronomer Jimmy Negus, and I saw my first total solar eclipse in 2017. We are here to show you how to watch an eclipse safely.
If you want to look at the sun, you must protect your eyes. These are not sunglasses. They're 1,000 times darker, and they're made for looking at the sun. Tens of millions of people have used these to safely watch eclipses.
And during an eclipse, it takes the moon a little over an hour to cover the entirety of the sun. Depending on where you live, you'll see more or less of the sun.
The only time you can look at the sun without eclipse watching glasses is if you're in the path of totality during just the few minutes when the moon completely covers the sun. So it's really interesting, right, to see a partial eclipse, but you went to the total eclipse. How was that?
Absolutely. So the total eclipse, if you have the opportunity to see, is absolutely worth it. It is very stunning and sends chills down your spine.
You will remember it your entire life.
Hi, my name is Christian Greer, President and CEO of the Michigan Science Center here in Midtown Detroit. And August 17, 2017, I was in rural Missouri on the center line of a total solar eclipse. And I'm there with my family, and I told them all about the eclipse. You know, it's gonna be this incredible thing, and it's gonna be awesome. So my wife is like, yeah, you know, like, you've been talking about this forever, we're finally here. So she goes up and we start watching the eclipse happen, and all the things are happening around us. And my wife is just like, oh, wow, oh my God, this is incredible. I'm like, I told you, I've been talking about this for 5 years. This is an incredible experience. But sometimes it takes people the opportunity to actually go and see the eclipse. It's so cool to see, and it's something that I think is a lot of fun and something you won't forget.
I was in a huge crowd. Some people were screaming in amazement. Other people were struck silent in awe, their mouths literally hanging open. I did both.
The first time I saw an eclipse totality, I have to be honest with you, I cried. I had an emotional moment of just the awe of what I was seeing, the darkness around me, the animals that were coming out. It was unbelievable.
You're incredible. Unreal.
Question. Okay.
Parents and students are getting bombarded with misinformation when it comes
college admissions advice.
oh, you need a perfect GPA, a 1600 SAT, and all these awards and accolades and volunteering and blah, blah, blah. Look, if you want to learn what it really takes to stand out and get into a top-ranked college, no matter how competitive it is, then you need to work with those who have both done it themselves and have also successfully guided others to do the same. My name is Jordan, and I'm the co-founder of Emission Science. My co-founder David and I are both Harvard grads, and coming out of high school, we're both accepted into every Ivy League school plus Stanford. But more importantly, through Emission Science, despite these record low acceptance rates, we've still been able to consistently help students get into top-ranked colleges, including Harvard, Yale, Princeton, Stanford, Cornell, Columbia, Duke, Northwestern, you name it. Now,
YouTube is still
before you get the
running
wrong
on the
idea,
video.
let me be clear. We do not teach gimmicks or tricks. We do not advocate gaming the system. We do not ask students to manufacture fake images.
You said we found everything that could go wrong. Yeah, it's definitely not these mics. So this mics. Oh my gosh. Can we work this way? Can I project? All right, well, we can fix this for the next guy. All right, so let's go back to the slides. Right, so Punch is a NASA mission. Here's the who, what, where, when, why, how, but in brief, there are 4 satellites we're launching into a polar orbit. We're going to study how the corona becomes the solar wind. Now, that's the first, well, we'll come back to it, but the outer limits of the solar corona, there aren't any. The corona expands outward, and during the eclipse, people will see it fade into the background brightness of the sky, but it actually extends all the way past the Earth. We are immersed in the corona. So we're used to thinking of the sun as something far away. It's not, it's close, and we are immersed in its outer reaches. And so what we're doing with Punch is examining the boundaries between what we conventionally call the solar wind and what we conventionally call the corona. It is an extension of what you see with your eyes. So it's important to realize the corona extends across the entire sky. I'll go forward here. Let's see, here we go. So why do we look at the corona from space? Well, we can see the corona only every once in a while, right? This is a Druckmiller and Aubele preparation of the 2017 eclipse. You can see the incredible detail we can see from the ground. We can't see this much detail from space. And the reason for that is not that it's not there. It's that you have to design an instrument for space to have the living daylights shaken out of it and still work, right? You mount these things on enormous rockets and shake the heck out of them, and then they have to work for years afterward. And so the result is that they're not as good as what you as an amateur can deploy at the eclipse. But of course, we get to see the sun all the time. So to compare, this is the most detailed view of the outer solar corona that was ever made. And you can see, yeah, it's detailed, but it does not stand out the way that Druckmiller picture did. And that's the reason why is the instrument itself. The outer corona is something that you probably won't see unless you bring special cameras to the eclipse, because even at this distance, about 4 or 5 solar radii from the sun, it will have faded into the sky brightness. But Punch will be looking much farther out and seeing stuff. Incidentally, I wanted to pause here and point out, I think I mentioned it before, people don't even think to wonder what an electron looks like, right? Electrons, the things that are powering the lights. This is electrons. When you see the solar corona, you are seeing electrons. There's ions mixed in with it, but the ions don't reflect sunlight, or at least not as much. Okay, here's an example of the corona extending all the way out into the solar system. This is from a few years ago now, taken from the Stereo spacecraft. And what you're seeing is kind of a weird projection of the sky in polar coordinates centered on the sun. So the limb of the sun, which should be a circle, is a straight line over on the far right.
and you've got a logarithmic scale of radius, right? So 1 degree is the size of your thumb at arm's length, right? 10 degrees is the size of your fist at arm's length. And over on the far left, you've got 90 degrees from the sun. So this was stereo looking back toward the Earth from heliocentric orbit. It was orbiting the sun, looking back toward us. It had this suite of 5 instruments still operating called SECI that were designed to track coronal mass ejections, the origin of space weather. And here you can see one forming deep in the corona, the movable loop, and extending out through the parts of the corona you'll see during the eclipse, and crossing all the way over the void, sweeping past Venus and impacting the Earth. This gauge here is being driven by an in situ spacecraft that was sampling the solar wind near the Earth. So as you can see, as the CME sweeps over the Earth, the density gauge tags. Really neat. So what Punch is doing is imaging this area. Of course, there's lots of interesting changes in texture and so forth of the corona as you go out and of the solar wind. And you will notice that true to form, the interesting stuff always happens right at the boundary between instruments. So the Punch field of view extends seamlessly from the outer corona over on the right, all the way out 45 degrees from the sun. So once it flies, we'll see the material that you're seeing during an eclipse coming all the way across the sky, sweeping over the Earth. Really neat stuff. And over on the right, that's the view in real coordinates of the stereo fields of view. The sun at the center, it's barely visible, but it only covers near the plane of the ecliptic. And so Punch will cover all the way around. We're excited about that. This is just so you have a picture of what Punch is. We're building 4 spacecraft. There's each one carries 1 instrument. On the left is NIFI, the Narrow Field Imager, which is a coronagraph. That's a telescope in the back, looking through a very, very deep baffle with a small occulter in the center that blocks out the sun. And over on the right, you have the WIFI, or Wide Field Imager. We have 3 of them, and those are very much like a coronagraph, but in linear geometry, so that comb in the front is intended to be an artificial horizon that the camera hides behind. Now, why do we have 4 of these? Well, the problem is we have lots of data. We're going to take polarized images. The P in Punch is for polarimeter, which is a polarizing camera. We do that in order to measure the shape of the corona in 3D. The corona is polarized. If you bring polarizing lenses to the eclipse, you will notice that the corona is polarized. And the degree of polarization lets us measure where things are in 3 space. That's kind of neat. We're doing that with Citizen Kate, which you'll hear about from Amir shortly. Where was I going with that? Oh, right. So we have lots of data. We had to get it back. We had to keep the spacecraft near the ground stations. And that meant there was a planet in the way. So we had to spread out the instrument to make it larger than the whole planet. The only way to do that was to mount it on multiple observatories. So over on the right, you can see our orbit, sun at the left, 4 spacecraft going around. On the left, you see a movie of their fields of view on the night sky. And as the spacecraft orbit, they paint this trefoil on the sky, and they go round and round and paint an entire 90-degree diameter circle. Now, 90 degrees is easy to say, but that's from the horizon to the zenith. So the only proper way to display our data is on a film. Right. So anyway, this will be going around and doing its thing. It's important for us to combine these exposures on the ground seamlessly. It's easier said than done. We're developing techniques to produce truly seamless images, and we're demonstrating them with Kate. So that's a direct tie where we have citizen science for the eclipse, which you'll hear about, that is directly helping what I consider a major NASA mission. So going back, I just want to drive home how large this field of view is and how large the visible corona would be if your eyes were sensitive enough. So here's that image from Druckenmiller and Aubele. This is the same corona photographed through an SLR camera by Dr. Emil Kepko out of Salem, Oregon. And you can see some familiar objects near the bottom, roof lines and trees and things. This, I couldn't even fit it on the slide. This is the Punch field of view on that picture scale. So extremely large. Whoops. Oh, can we go back one slide? Sorry. So I'll wrap up here. I thought I had two versions of this. Okay, yeah, it's got all the labels. So we'll image the surrounding solar wind. The key thing to take away here is we are immersed in the solar wind, which is an extension of the solar corona. And so when people think about the eclipse, and we're training them about what the corona is, you need to think of it not as a distant object, but as something that we are immersed in. And we're working with Citizen Kate. We have a punch outreach program. I've deliberately not mentioned it. You've heard the word punch a lot over the course of this workshop. You're going to hear from Dr. Cherilynn Morrow next, who will talk about what we're doing in the way of outreach, building on the eclipse. Thanks. You can try this, or you can project. That you won't hear that. Here, I'm going to turn this one on. This is the room light, but you need both of them.
Or you want, I'll take care of it.
All right, very good. Yes, thank you, Craig. And we are, as part of our outreach program embedded in the NASA Punch mission, we are, okay, good. Yeah. We are developing a planetarium show in collaboration with this planetarium in Boulder and in partnership with this museum, the Mexico Museum of Natural History and Science, the Lowell Observatory, and Clark Planetarium in Utah. So we have a four corners kind of collaborative. You all can hear? Yeah. Yes, great. Yes, so the way to do it is on the dome, and that's the way we will be doing it. I want to get a little more local, and also before I get started, want to acknowledge the team members who are present. There's a single name here, but there's actually dozens and dozens of people, several people who are here helping to run the resources upstairs and hopefully talking and interacting with you. Could you just raise your hand if you're part of that team? Yes. Jason Trump down the back, Mike Sagaski, Stacy Wolf, Jayne, Aubele. Oh, great. And Punch Outreach is also paying for many of you. We hope you're here to be present here because we really care about this region with regard to the annular eclipse and are really happy to be collaborating with the Eclipse Planning Workshop. So shining new light on diverse views of the sun with our ancient and modern sun watching theme. That kind of sums us up. And here are the different dimensions. What do we mean by diverse views? Let's pop to the next slide, please. This is a little bit of an unpacking of the ways in which we are addressing these diverse views of the sun. And you're hearing about many of these ways. We want to emphasize a little bit more the cultural and historical here. We're very grateful to Craig DeForest, the principal investigator that you just heard from, is creating a very friendly environment for outreach embedded inside a NASA mission and allowing us, in fact, to have this thematic approach, right, with the ancient and modern sun watching theme. Let's go ahead, which involves not just Punch, but other heliophysics missions. So there were three elements to our ancient and modern sun watching theme. Punch, solar probe. How many have heard of Parker's solar probe? Yes, if you're paying attention, you know that's flying in the corona, as well as Punch looking at the big picture, right, of the space between the sun and Earth. And so we want to make sure that we are being friendly and illuminating other missions along with ourselves. We are framing NASA exploration of the sun as a natural extension of age-old human practice of observing the sun's rhythms and histories. This part of the country is extraordinary for continuity of solar observing in the ancient ways. And so Chaco Canyon, how many of you have been to Chaco Canyon? Yes, many of you, please go. You'll have great excuses to go. This is our primary partner in elaborating our ancient sun watching dimension. More than 20 indigenous tribes are linked historically or ancestrally to the canyon. It's a World Heritage Site. So not only does it serve this region, but it's of global interest as well.
Oh, sorry.
There was a pause, but yes, if we go back, there we go. The idea is to make NASA heliophysics of personal and cultural relevance, right? And so how do we make that bridge? And so personal sun watching and the eclipses are an extraordinarily great opportunity to encourage people to become sun watchers. Not only though in the extraordinary way, but in the everyday sunrise, sunset way. So the aim for us with this ancient and modern sun watching is to take full advantage of these eclipses coming up. But also this theme transcends the eclipses to encourage people to become sun watchers in an ongoing manner. That you would then have experiences that would connect you to the culture and connect you to NASA missions both as you stand there and experience the sun. Yes, thank you. So here are partners. If any of you are emphasizing any of these types of partners, we want to talk to you. Right? And we want to emphasize that some people you think might not be interested in the eclipse because it's such a visual spectacle are actually very interested, like blind and low vision members. And other people that you think might want to hoop and holler actually want to be inside praying and fasting. And that's something about this region as well that we need to be sensitive to, that people arrive in different ways and manners in regards to their sensitivity for sun watching. But these are folks with whom we are collaborating to be of benefit to everyone. These partners have helped us. We don't have target audiences, we have collaborators who are helping us to be of benefit to everyone. So we're developing these tactiles. You'll be able to see them upstairs during the resource section. We're focused on girls in STEM, and we have an ancient and modern sun watching patch, which again will transcend the eclipses. The 8th graders there in the picture with hands on the upper left have taught us that palms are more sensitive to the direction of the sun, and perhaps palms up is a better way to make pinhole projections with your own hands than with your backs of your hands up. Give it a try, see what works best for you and the people that you're teaching in this way. Please go ahead. We had an incredible sun fun day at the Pueblo of Acoma, just 50 miles west of here in Albuquerque. Again, making personal and cultural connections to sun watching. I'd like to introduce, these are family members of our primary Acoma Pueblo partner, which is Mr. Joe Aragon. And Mr. Joe Aragon is sitting here. Would you say hello? Yeah, thank you. Yes. And we just made a connection with Marlon Magdalene. Is he here? There he is back there from the Hemis Pueblo. And so we are aiming to seek partners in the region with whom we can be of benefit. By the way, that prominence showed up in that telescope just to help us celebrate the sun on that day. Yes, okay, next please. So I won't dwell too much here, but we are in partnership with the museum. We have these, what we call solar protection glasses, because some people will look through them, and we look through these even when there's no eclipse, right? So when there's an eclipse, it's going to be exciting, but I would encourage you to make use of these kind of resources in the preparatory. Somebody mentioned how important it is to prepare people, right? And I think that was you, Derrick. And so these are resources that you don't have to wait to the eclipse, right? To train people up. And so there's demonstrations upstairs. There's a solar telescope upstairs. This is a small subset of the people that we are wanting to support in being here with the Eclipse Task Force and elsewhere. Next, please. So again, here is what it can look like, as you all know, during something close to an annular. Next, please. But again, pinhole projection happens every sunny day in your environments. And we would really like to be advocates of this eclipse is a way of connecting people to the natural world in an ongoing manner. And because pinhole projections are so pervasive, both flowing in your window through leaves, we have to train people how to see them. It's a miracle hiding in plain sight that we have an image of our star, right? Almost everywhere. And so we encourage you strongly, not only to the use of our projector, kids who see those round images appear, wow. And we have a cool indoor demonstration that we'll talk about more later. But this, whenever sunlight is filtering through leaves, we can get images of the sun. So begin to look for it and begin to encourage others to pay attention to it. And when there's an eclipse, they'll know how to pay more attention. Next, please. This is just another eye candy of the variety of environments in which pinhole images of the sun can occur. They really are everywhere. Chaco, quickly go ahead. There is special petroglyph in Chaco that you can go see. It's near the visitor center. This has just been open to the public. There's a ramp that goes up where you can see that petroglyph, which is very peculiar, but for lots of reasons may be interpreted plausibly as a representation of the 1097 total solar eclipse during a time of high solar activity. And so we'll say more about that in later sessions. I want to draw your attention to this 3D print of that petroglyph based on high resolution photography. And so you can get your own hands on this as well as the thermoform. To close up, that pecking up in the left may be Venus. It was off in that direction from the start. Next, please. So our niche is this. This may be the first representation of an active solar corona in an enduring medium known. So certainly coronal representations have gone back millennia BCE, but this may have some activity going on. Notice that tail in the lower right. There may be a CME going off during the 4 minutes of the 1097 eclipse when we are seeing the solar atmosphere. Let's go forward. There's a more close-up. We're testing the innie versus outie version of the eclipse petroglyph with a learner from the Colorado Center for the Blind. Next, please. New twist, pottery at the University of New Mexico here in town. The Maxwell Museum, somewhere in their collection, and we're going to go search for it on Tuesday, is this hand-sized bowl, same size as the petroglyph with that solar motif. So the cultural pot thickens. Next, please. We'll talk more about this. This is the punch source of resources. And I don't want to dwell here because we'll have other opportunities to go into greater detail with these great products that are coming online. Next, please. I'd like to turn it over to Jayne Aubele just for another couple of minutes to flash through and acknowledge the names of people that are being attentive to the this planning workshop regionally. Thank you. Action was taken in 2012 at Petroglyph National Monument, right here in Albuquerque, when we had an inside. But we will have another annular eclipse, and we're very fortunate with 10 years, 2 annular eclipses. We won't see another one in Albuquerque until 2238. So if you miss this year, you got a long wait. In Albuquerque, it will begin around 9 and last almost 3 hours. And full annularity is around 10:30 in the morning, which means pretty high in the sky. And everywhere in Albuquerque should have a few. Next, we expect 150,000 people potentially that day because it's so voluminous. And all of these folks, national major organizations, expressed interest in coming here because of that we are ground zero for the annular eclipse. Next. So all of these folks are partners with us. Next, we have put together with them a coalition. We're all next going to offer viewing locations for pre-eclipse program. Next, farther afield regionally, we have some folks at this one. And that's it. Thank you.
Thank you so much. Okay, coming up, last and final, Amir Caspi from Citizen Kate. We've been hearing all about it, it's all online too. I think so.
Sorry that these talks are a little bit out of order, but I'll try to be quick since I'm keeping you all from lunch, but I want to hark back to what Craig talked about, which is the science of the corona and how that impacts individual people and how we can bring that to the public. Craig showed you this picture of the solar eclipse. This is not exactly what you see with your naked eye. This has been highly processed to bring out all the detail and contrast. What you see with your naked eye is in some ways more awesome because you're there in the moment and you're seeing it with your eyes. And in some ways, of course, you don't see all these details, but what this highlights, what you're seeing here is the sun's magnetic field. And the bright stuff that you see is hot plasma. It's ionized gas that is acting like iron filings in the magnetic field. It's tracing out that magnetic field. We can't see this magnetic field with our eyes. We can't even measure it with our instruments, but we can see the traces of that field through this plasma. And eclipses give us that insight that we don't normally get from space. As Craig said, you have to put telescopes in space that don't give you the same quality you get from. And we're still trying to answer lots of questions like why corona has this kind of structure. What keeps it in that kind of shape? Why is the corona so much hotter than the surface underneath, which you haven't necessarily heard about previously in these talks, but it's one of the mysteries of the corona that we're trying to solve. So there are changes that happen in the corona on minutes or hours or days, but there are very important things that you can't see from space and that you may not be able to see from the ground. And that you can see during total solar eclipses. But part of the problem is the shadow moves really fast. In fact, at its slowest, the shadow is usually moving at around 1,500 miles per hour, right? So it's faster than any commercial jet. It's not quite as fast as all supersonic jets, but it's still very, very fast. And so when you're at one place on the ground, you get a few minutes, right? And it's hard to see things changing in the corona over just a few minutes, but if you could somehow watch for an hour or an hour and a half, then you can start to see things actually changing and happening in the corona. And you can't do that from a single site. And it's very hard to chase the shadow because it moves so quickly. But if you have the shadow chase you, then you can do that, right? And then if you put a lot of stations along the path, then you can look at each one as the shadow passes over them. And if you play your cards right and you make the observations correctly, you can put them all together as if they were one single instrument and then get a movie of the corona for an hour. And in fact, this was pioneered back in the 2017 eclipse by Matt Penn, Bob Baer and company in Kate 2017, where the eclipse passed over the entire United States. Every individual site had only about somewhere between 2 minutes and 2.5 minutes. And so they had 68 different teams spread out across the United States with 300 citizen community volunteers. They don't have to be citizens, but citizens of the world, community volunteers that ran telescopes. They were trained on how to use them. All of the telescopes were the same. They were given that equipment and they put all of that together to make an observation of corona. I do want to point out that they do have another project coming up called DEB. If you have questions about that, talk to Harvey. Since Bob is not here, the website is right there. They're revamping their K 2017 initiative with new instruments, trying to make it easier, less expensive, more accessible to people, and try to address very similar science. In our case, we're doing a different offshoot of Kate 2017, and we're going to start making images of the polarized solar corona. So just to make sure everybody knows about polarization, of course, light is a wave, and it waves in a particular direction. And if you have polarized sunglasses, you've seen this in action, because when you wear these polarized sunglasses, they cut out reflections from water or water on the roadway. And that's because that light, when it reflects, is in a particular polarization. It's in a particular direction that gets removed by your sunglasses. And light from the corona is also polarized. And this is an image that we took with the Kate equipment in Australia, in Exmouth, just a few months ago. And the different colors that you can see here are different angles of polarization. So here, here's, you can even see it better. Here, the different colors actually represent all of the different angles of polarization. You can see that changes as you look in different areas of the corona. And if you look carefully, this can help you understand what are the various processes happening in the corona. Now, just to give you a sense of scale, how does this relate to Punch? Punch doesn't see anywhere near this far down. So right now you're looking at the sun plus about maybe 3 suns worth onto the edge. We have instruments in space that can look out to about 6 suns worths. In fact, they can actually go out to about 32. But Punch, you know, what we're going to be observing is that inner bit. And then this is the inside instrument of Punch is going to see this much. The near field imager is going to observe, or narrow field imager observe this much. And in context, this is, you know, how big that is. So this gives you that same sense of scale Craig was trying to give in a different way. Why is this important? Because, you know, Punch is going to be looking at how space is filled with the solar corona and the solar wind. But it's hard to understand how that happens if you can't see the origins of the sun. And so solar eclipses tie what Punch will see to how that was born at the surface of the sun. And even though the 2024 eclipse will be before Punch launches, Punch will be up during future solar eclipses that we can merge together. So we are going to be running this experiment. We're going to be recruiting 35 or more teams that live along the 3,000 communities that are along the path. And one of our goals is to reach into traditionally underrepresented and overlooked communities and try and make sure that we can bring them into the love of science and help give them the opportunities to interact in ways that they may not normally have. And our educational team is also partnering with the Rising Voices Network and other community organizations to partner. But one of the ways that we're doing this, we know that we, at the scientist level, we don't have a lot of insight into what local communities are like. We don't necessarily have a lot of insight into how local communities interact with the sun, with science, with scientists. And so we have this sort of hierarchical structure that help us provide that inReach in a more intelligent fashion than we could do by ourselves. So we have these regional coordinators. Our Southwest coordinators are at Rice University. Our Midwest are at Indiana University, and Northeast is the University of Maine. And once we get our major funding package from NSF, we're going to begin recruiting, hopefully in just a month or so later this summer, for our state coordinators. And those state coordinators will have a better understanding of what their local communities are like, and they will help us recruit local teams. Each state coordinator will be responsible for about 3, 4, 5 local teams. And so that spreads the work out amongst all of the folks and also makes sure that everybody has the insight on how best to interact with those local communities and what this science might mean to them. And just like with CATE 2017, just like with the DEB initiative, CATE 2024 wants to deposit equipment into those communities so that they can be a resource in the future. We want to deposit educational curricula so that those telescopes will be useful, not just for this eclipse and not even just for sun watching, but for future science. And so if you're interested, please shoot us an email. We're also on Twitter, behind Craig's knee. If you're interested in DEB, please talk to Harvey, and hopefully we'll have a great solar eclipse. Thank you.
Okay, everyone, we need to break for lunch now. We have we have 2 questions. Do you want to come here? Let's see if we can do that quick because we're 10 minutes behind. Yeah.
Oh, where's the microphone? Patricia Reef asked, how can Punch imagers handle the extreme difference in brightness across the images?
Sure, I can answer that fast. The answer is we combine many techniques. One is we have 2 different types of imager, partly because of that difference. Oh, is that what's going on? I don't know. Oh yeah, look at that. Well, okay, so actually, the other way, yeah. So they have about a factor of 1,000 across each imager, and there's a combination of just a very linear camera, and we use vignetting creatively to reduce the brightness at the focal plane in the brighter part of the image. So it all works together, and then we have 2 steps because we have the inner and the outer. So that's it.